Hello and welcome to another Developer Toolkit. So this time around, we're going to take a look at how we can customize the inspector. So there's quite a few different sort of aspects to this, and it's something where it's very easy for customizing the inspector to get super frustrating. So we're going to walk through fairly carefully the different ways in which we can modify it and look at some of the problems that we can run into and how we can actually work around those problems. So let's dive right on in. So what I have set up to begin with is just a really simple class that we can control the bounce period, the bounce height, and it allows this cube to move. So I want to start with something fairly simple. So to create an inspector for this, we need to there's a couple of ways we can approach it. We can often set it up in a separate file. We can also put it in the same file. Each one requires sort of different ways of handling it. I'm going to show you initially having it that we set it up in its own standalone file. So immediately there's going to be a particular thing we see different. One of those things is I'm going to create a folder that I call editor, and I'm going to put the custom inspector code in there. Unity treats a folder called editor differently. Regardless of which subfolder it's in, editor will get treated differently. And in particular, what it will do is when we go to build our project, any scripts that are contained within that editor folder won't get included. They get ignored. And that's important because our custom inspector script is having to access a lot of systems and things that are only available within the editor. So those aren't accessible when our game is running. So we have to do a bit of partitioning of our code. So putting things into our editor folder where possible, and those, as I said, we can have multiple of those. They can be in different locations. That will actually help with that. So that immediately means that code won't get built when we're creating a build. There are ways that we can work around that because there might be cases where our editor code needs to talk to our game side code, and that's something we can handle, and we will take a look at how we can actually do that. So the script is called simple behavior. So the general convention is that the editor script, we name that whatever the name of our class already is, and then editor in this case. So editor is usually used if what we're doing is something that is fully customizing something that is appearing at the top level of the inspector here. So the inspector for a component, we would normally say that that's an editor that we're actually doing. Now, one of the things we need to do with this immediately is rather than bringing in Unity Engine, we also need to bring in Unity Editor. So it's one that we haven't previously brought in, but it's one that we're going to need for being able to do this. Now we get rid of our start and update because this isn't based off of mono behavior. This gets based off of editor, and we need to tell Unity that this class is going to handle doing the editing for our simple behavior. So the way we do that is we say, well, this class is a custom editor for the type of simple behavior. We can also, there's optional abilities to usually indicate whether this will work for child classes off that. But in this case, we don't have child classes for it. So we can start off with just this. So let's see what happens when I do this. If we see any difference to begin with. And initially, nothing changing. We haven't actually put any code in here, so none of our code is actually running. So what we need to do then is we need to actually start to control what is actually happening here. So we do that by, there's a couple of key functions we'll often use. So one of the ones is a void, doesn't need to be public, on enable. That is a good spot for where we can cache various bits of information. The other one then that we do override is we have override void on inspector GUI. And this is the one that handles the actual drawing of the inspector. So if we check with that, now we will see we need to make sure that we have to actually have this be public. So whereas a lot of internal ones are actually able to be private, in a case like of this, has to typically be public. So we can run that. Now, because we had errors, we didn't see any changes there. Now that that's compiling, we don't see anything because we've completely overridden the drawing and said, no, there's nothing to actually do. What we can do at this point then is say we wanted to draw just the default inspector for this object. Draw the default inspector. Then we can say draw default inspector. So that's something we've got access to. If we do that, then we should see we get all of our previous things back. And that can be really handy if we wanted to do something where what we then did was, okay, let's draw a button. Now, the way we draw buttons in things like of Inspector GUI is quite different. If you have worked with styles of UI referred to as immediate mode GUIs, then this is what we're working with. It's an immediate mode GUI. What immediate mode means is that same line that you use to draw something is also then actually providing information back. So a clear illustration of that is we can do f Gui Layout dot button, and then here we might have randomize values. So the same line that draws the button returns true if that button is pressed. So for now, I'm just going to put out a message just so we can see that it's working. So this can be really handy where it might be you just wanting to use all the normal inspector stuff, but you wanting to make some minor tweaks and additions. So with this, well, randomize values, and we can see it's running. So that's good. So, okay, we've got the ability to do this. What if we did want to actually randomize those values? So this could be something where it could be good to actually now take over the drawing of the particular elements. So we can actually do that. So this is an editor for a simple behavior. That's the thing that is being edited in this case. It's editing a simple behavior. So we can actually do stuff where we then specifically access that. So for example, we have this thing available to us called the serialized object. The serialized object dot target. So we can take a look and see what that actually is. So if we do a debug log out of that, because this is something that we have access to in our inspector here. So we'll let that run, we'll see it output. So we have access to our simple behavior script, which is what we would expect. So serialized object.target object gives us our information there. So then if we want to draw the properties, well, we actually have access to stuff here where, we've seen, okay, Gui Layout. We have the ability to draw things like buttons and that with it, but there's actually more that we can draw than that. And we also, as well as Gui Layout, we also have Editor Gui Layout. And that's going to allow us to actually draw some of those property controls. Okay, so to draw these things, if we take a look at what we've got access to under Editor Gui Layout, we have a bunch of different things, and this is where we can start to have some fairly complicated setups. And we have, in particular, a lot of these ones that have field in their name. And so these are ones that are going to be drawing particular editable controls. So we can see we have varying ones for integers, for tags, colors, curves, all the different sort of ones that we could have there. We also have some fairly generic ones. One of the key generic ones is this one property field. In most cases, unless you're needing to really carefully control how something appears, a property field will actually do what you need. But this takes in this serialized property variable. So we know we have a serialized object, but we need this serialized property. And remember, I said onEnable is a great place for caching things. This is an example of some of the things that we would cache. So our simple behavior has a bounce period and bounce height. So what I would often have is serialized property, bounce period prop. And the serialized property, bounce height prop. And then in onEnable, we can retrieve those. So bounce period prop. Well, we know we have a serialized object. So we have a serialized object, and then we can do find property. And we just indicate the name. Bounce period. Same thing for the height. So this just allows us to retrieve those properties. So serialized object, again, find property, bounce height. Then property field, well, we just say, okay, well, bounce period, added a Gui layout, property field, bounce height. And so, okay, those look pretty good. Let's see how that works. We've hooked those up. We have turned off now. I'll turn off the drawing of the default inspector, so we're manually drawing stuff. So we should expect to see those two fields there largely looking as they were before. So we can click on it, and yep, we can see them. And we can, well, I suppose the thing, we can't change those. And that's because Draw Default Inspector does more than just drawing things. There is a lot more that it's actually doing than just that. What we also need to then be doing is we need to be telling our serialized object to apply modified properties. So when we're working with things in the inspector, we need to actually explicitly indicate our intent that we are modifying things. So now with that, we can check and see that we can actually be able to modify things. So now we can see that that changes. If we go back to the cube, so that looks like it's properly changing. So as I said, there's extra processes we have to go through in the editor because the editor supports undo. So there's extra steps we have to do to ensure that that undo system has the information that it needs to be able to perform its tasks. So, okay. We'll leave turning during the default inspector off. Draw the two properties. Should we randomize the values? So now, because we've got access to these properties, we can actually start to randomize those values. So what we could do is, okay, bounce period prop. And if we want to access its value, we've got lots of these different value members here. So in this case, we know we're dealing with a float. So we could say, well, a float value, and we can now randomize that. So the height, that might be a random range, and maybe we want to allow that to go as small as 0.5, but allow it to go up to, say, 5. And maybe the bounce period property, we want to make sure that. So bounce period, let's say we can allow it to go as fast as 1 second and as slow as 10. So we've randomized the values here. Now, something that we might run into, it looks like it's okay. It's not having any specific things we need to manually do to say it's been modified. That could have been a thing we run into. Part of the reason for having likely those float value properties in that is so that there is a layer it can put in between for detecting and flagging those changes. Because now I should be able to go randomize values, and it will. And I should then see those are being remembered, which is good. That's what we want to see happen. So, okay, we can randomize the values there. Great. Because we're going through the property fields, that handles a lot of sort of weird edge cases for us. So let's do something where it won't handle weird edge cases. That's randomize values version 1. Let's set up randomize values version 2, which what I want for version 2 is I want this randomization to happen back in this code. So I mentioned before that we can have, run into issues where, because for this, it's going to be modifying code. That means that because I'm not directly going through properties, I have to talk to the undo system, which means I need to bring in Unity Editor. But then if I tried to do a build, this wouldn't work because Unity Editor is not accessible for this script when I do a build. And I could put this script in the editor folder, but then the script wouldn't be accessible to things. So I need a way of having it that this script presents different versions of itself depending upon the context that it's running in. And I can do that. So what I can do is say f Unity Editor. Could type the specific version. In this case, we don't need to. We're just checking the Unity Editor. And f. So what this will do is this line will only be included in code where this is defined, which Unity automatically does that behind the scenes for us. That means that I can set up an entire function here, f Unity Editor, and this function will only exist when we are running within the editor. So void randomize values. Now I can use largely the same code from here, except I don't have properties. In this case, I'm directly changing these. So the bounce period gets directly changed. The bounce height gets directly changed. But as I mentioned, we're dealing with stuff where we need to actually communicate that to the undo system. Because if I did this, these changes won't get saved. Unity will only save things when it knows that they have been changed. So it's a way of making it more efficient. And this can get really confusing because I would run this, it would look correct in the inspector. I could run the project and it would be fine. But as soon as I switched scene, for example, or closed and reopened the project or tested in a build, this data wouldn't be remembered. So we have to actually be working with the undo system so that it knows stuff has changed. And the way we do that is we can go undo, and we've got a bunch of different record things that we can be working with. Some of them are specific to very particular actions. So there are, for example, record ones for when we are instantiating things. So if we're instantiating something, we should absolutely be using those particular ones. So it's important to make sure you're using the correct type of one. So the key thing is these are done, it records changes done on the object after this function runs. So we're going to say record object. The object to undo, in this case, is ourselves. And we say what the action is, randomizing values. Now, generally, we can't see the particular text for this, but there are upcoming changes to the Unity editor that will actually make that stuff be a lot more visible, which is really cool. So always helpful to make sure you set these to correct, valid things that describe what's happening. So, okay, we've made our code safe here so that it will work with a build. These sections effectively only exist in a narrow circumstance. we still need to be able to talk to our object. We know we've got this serialized object, and we know from before that we could do serialized object.target object, and that was our simple behavior. So we can actually cast this to our simple behavior as simple behavior. So linked object. So we've cast it, and then we can say linked object dot randomize values. And we're doing the apply modified properties afterwards, so we should be correctly syncing if there are any changes, but let's check. We randomize our values, and we can see things are changing there, which is good. So they're currently sitting at about 6.1 and 1.0. So what I would generally do in a case like that for testing it is, if I even just go to an entirely empty scene and then go back to our custom inspectors one, we can see the values have been persisted. So key things with setting up this kind of inspector: we need to override or set up our onEnable function. That's where we can cache a bunch of information. So for example, our particular properties. And you'll notice this find property finds it even though these are private. So these properties don't need to be public for us to be able to access them. They don't even strictly often need to be serialized field, and we'd still be able to typically find them. So it's able to access those properties. We can cache them in onEnable. Then in drawing, we can just draw the default one, but that draw default does a lot more than just draw. It draws them, but it also then tracks any changes. So if we're wanting to draw it manually, property fields are a great one. We can use custom ones, so make it explicit of the particular type of one. But if we just use a property field, it'll auto-determine what type of thing to be doing there. We can add in buttons, and the way we work with these is we do an if, and they will then actually pick up if it's actually being pressed. So we can randomize our values directly through the properties, or we can grab the object and talk to the object itself. So we have that as an option for us. And then at the end of that, we do apply modified properties to make sure any of those changes are properly tracked and synced. So that's pretty cool. But we can do more than this, because let's take this a few steps sort of further, because our simple behavior, okay, that's a decent setup. But what if we have a custom class within this? So serialize field, and system.serializable, system.serializable, public class, config. So our config, it's not based off of mono behavior. We're going to give it a couple of properties. In this case, I'm just going to have them be serialized field as well. And that can be string ID. And let's have float value. And let's also put in an enum as well. Let's have a nice sort of mix of one. Public enum e type. So maybe we have float, integer, string. So we'll also then have in here int value. Just so we can, the idea kind of is we're allowing this to potentially store a lot of different types of things. So we can have a string value, and then a final one is going to have the type. For that value type. So, okay, we're going to set this up so we've got a serialized field, and we have config configuration, and we're actually going to make it that we have a list of these, because it would make more sense to have many of these. The configurations. And this, we can pretty quickly get it so that it's able to be being drawn, because we can have our property field here, serialized property, configurations prop. So fairly quick to add in new ones, which is great. Find property, configurations, and we'll do this. So let's take a look and see how this looks. See if we immediately get it and it's looking sort of a way that we're happy with. So we can select our cube, we can see configurations. So yep, that's looking all right. But one of the things we'll notice is, depending on what type I've got here, I really don't want to show all of these. I don't want to show every single one of the ones. I want to just show the value that makes sense, because otherwise that's confusing for people using it. It gives the impression that there's additional things that they need to enter in there. Not really a great user experience. So we can make this better. Now, because this is something where it's appearing not as the editor for a component, but it's appearing as a particular element within something, this is a case of where what we create isn't a full sort of custom inspector. We're creating something called a property drawer. And the way we actually have to work with this is quite different. So I'm going to set up, we still keep it in the editor folder, and we still follow a similar process where, okay, this was called config. So the file, I would create a file that I call config property draw. So this is going to look quite a bit different to the inspector, because with property draws, we don't get as many of the handy sort of helper functions as we do with the other ones. So they work a little bit differently. So first thing is, we need to, again, bring in Unity Editor. The editor, so we've brought that in. Now this inherits from property draw. And similarly, the attribute here is different. So we say this is a custom property draw for config. And our actual sort of setup for how this works is a little bit different. So we have a different function here that we are able to be using. So when we're actually doing this, rather than doing on inspector GUI, it's actually an on GUI function. So public override void on GUI. So this is how it looks. We can get rid of the base version. So this is quite different to what we've seen with the other ones, where we, because this one we've actually got properties coming in. So property corresponds directly to our configuration. So property in this case is referring to one of these elements of this. So we've got that, and then we've also got this position information. So we've got extra stuff coming in here. And we don't have the same sort of ability to just immediately, okay, cool, it's straightforward and we can just do a few property fields, done. Have to actually do a bit more work than that. So one of the first things we typically are wanting to be doing is we're wanting to be saying, okay, well, we're beginning our property and we need to give it a position, label, property. So that's typically where we would start with this. We're saying that we're beginning that property. We have similar thing to our custom inspector, where we're needing to tell it that things have been changed, need to be applied. So apply modified properties. So we still need to be doing that. And our editor GUI, we also then need to say end property. So these begins need to match with the ends. That's really important. So now we can start to control the appearance of this, because we've got access to this rect, which controls the position, so it allows us to actually control where stuff gets drawn. So we know for our config, let's start off with, we'll get the ID and the value type drawing. So first we need to retrieve those properties. We don't use the same onEnable thing as we did before, because this is getting run for multiple different ones, so we can't really do that. So what we'd typically be doing then is, okay, property. So there's different ways we could go for naming this. I'm going to go for prop ID. So again, we can say property, and apart from the autocomplete going a little bit wrong, we can go find, but it's a find property relative this time. So we search for ID. So that's good. We've got our ID there. Now we need to look at what sort of information do we have to provide to draw this. So for drawing it, we generally need to be using editor GUI, and we would then say draw property, which we can actually just directly access the particular stuff for being able to do that. So it would be our editor GUI property field. Well, it needs a position. So, okay, let's see what happens. We're just going to give it that position, and we're going to give it property ID, and let's also draw the type property. Now, this is going to not work properly. It is absolutely not going to work properly. That's an intentional thing, because I want to illustrate how this actually behaves and what we need to then do. And we will see this is going to look quite messy. So select that cube. So everything, and if I chuck in multiple ones, we can see all of the UI is being drawn on top of all of the elements. So that's not good. That's because this rect that we've provided here is just the default one that we've been given. So that's no good. We actually need to customize that for each particular one. So what we would be using here is a new rect, position.x, position.y, position.width, and now the height. Well, we can actually ask it, what is the height for a typical single line? So editor GUI, utility, single line height. So that's good. And I could use that down for this next one, but they're going to be at the same Y position still. So what we typically do afterwards is, okay, well, position.y, we add in GUI utility, single line height, plus, we want to have that little bit of a spacing, a little bit of buffer between them, standard vertical spacing. So we're just offsetting it a little bit. So let's see how that looks. So that's going to run, and that's better, except, well, the size of this list, it's getting the wrong size. And that's because when we're working with property draws, we have to actually provide a function to let it know how to actually calculate the height. So what we would do is, in this case, well, the property height, we know it's going to be single line, two of the single line heights, plus a standard vertical spacing, and wouldn't really hurt to chuck in an extra vertical spacing on top of that. So it could be 2 times by, we just grab this. So now it should know the height that it needs to be, and that will work a lot better. So now we can see straight away, it's actually looking a lot better there with that. So let's put in some particular values. Test 1, test 2, and test 3. And we want to make sure that it's remembering the types here. So string, so that looks pretty good. Get back to it, it's correct. Excellent. Well, now, based upon what this value type is set to, we want to show a different particular editor there. So in this case, show the ID property. value type property. Now we know because we're going to have an additional thing, we want to do the position.y again, and this is going to go to 3 because we've got larger set of data there. So we can grab the value from that value type field. So if we do prop value type, now with enums, what it has is the value index as an integer. So we have to actually cast that. So we cast that to an e value type. And if we take a look, what did we, e type is what we called it. E type. So value type. So we can just do that. That'll give us a cast version of it, because then we can actually go and check, okay, well, if value type is equal to e type dot float, otherwise if the value type is equal to e type dot integer, and then a final one for if that value type is equal to e type dot string. Now how these look is going to be pretty much identical to this. It's going to be really straightforward. These ones, we know that they will be things like float value, int value. So this is going to be float value. So property value. You can make a fair bit of this actually pretty generic. So all that then changes with these is, well, this one's referring to int value, and this one is referring to string value. So what we'll see is the different ones will actually have those different fields there. So we can see this one's showing the float value, int value, string value. If I change these 2 and 3, so when I change that to an integer, well, I don't see the string value anymore. So it means that we're not having to show all of the properties. So this is a really handy way of being able to filter the level of information that you're showing. So you're only providing through the data that actually needs to be there. We can also customize stuff a bit more in terms of these labels, because these labels, might not be really something that we're happy with, where we might want that just to be, say, type, or just to say value. So we can adjust that. Because when we're drawing the stuff here, and I'm going to bring this onto another line, we also can provide additional things. We can provide this Gui content here. So we can go new Gui content, and we can just say hi. Whereas with these, we would do a similar thing, except the Gui content would say value. Value. So it just means that we can fully sort of customize how the stuff is being displayed to the user, so we can make it as easy to use as possible. So we'll do that. So then we should see these say, value and type, which they do, which is good. So it means regardless of which type of thing we're seeing, we see the same information presented to the user. So again, it's providing consistency, which that consistency helps avoid there being problems and issues, which is really great. That's what we want to try and avoid. So part of the reason for custom inspectors is to make it more sort of robust and less error prone. But we'll notice these configurations, I can collapse this, but I can't collapse these individual ones. That's not great. I want to be able to collapse those too. So we can do that. What we do is we want to group all of this stuff into what's called a fold out. So what we do is I'm going to still retrieve this ID property, but I'm going to retrieve it up here. And there's a very specific reason why I'm going to be doing that. Because then what I want to do is I want to actually draw that fold out. So what I do is property, so there's already an isExpanded, and this is important. We want to work with that isExpanded variable. Don't go and set up your own variable. Use the built-in one inside the property. If you set up your own one, what will happen is you expand one of the elements, it'll expand all of them. So use the element that is expanded that's already provided for us. Then we can set a fold out. So editor Gui fold out. And again, we need to provide a position. So we provide that rect for it. So again, that rect is going to look exactly like our setup here. So provide that, and then it needs to know if it should already fold it out. So again, property dot is expanded, and then content. So this is why I grabbed that property ID out, is because I want to then make it so prop ID dot string value. The fold out is given the same label as the rest of what we're actually showing. So group variables fold out, and then all of these I only show them if property is expanded. If it's expanded, then I can show any and all of these. But that means I need to adjust this. So this becomes, okay, well, if property is expanded, then we just return that. Otherwise, we'll return, just for consistency, 1 times that. So just makes it an easy way of being able to group properties. We could set up multiple foldouts there. Key thing is you just want to be making sure don't set up your own variable, use the built-in is expanded one. Because if we run this now, what we should see is it should be looking a little bit nicer, but we notice, well, because the foldout takes up a line, we actually have to push everything down in the event that it is expanded. So if it's expanded, we actually are taking up 4. There is that 1 additional space because the foldout itself takes up some space there. So we do need to remember that. But now you can see our key appears here. So it allows us to make those labels a lot nicer. So it can, it's easier to read, easier to work with. We could be doing further UI customization there. But the key thing is it lets us be able to actually show this. So, okay, that's pretty good. We're going to chuck in one final thing to make this a little bit more complicated because, floats, integers, strings, sure, fine. Integer list, because we've got now a list of things within a property drawer. And that's going to be interesting. Integer values. We're going to take a look and see how that works. So it's going to be, a lot of stuff won't actually need to change. We know we can just pretty much steal our existing things here. So that's going to be called integer values. Can draw that. Prop value. That looks pretty good. Integer list. So in theory, we've seen for other ones, so that's what we need to do. We don't need to do anything more complicated than that. That's fine. Will it be though? We don't have any integer lists currently, so let's add in another key. This will be test 4 and integer list. And well, this is a problem because this thing's a variable size. When we're providing stuff like get height, we need to actually provide the height of everything. So including child properties there. So that means things like this using single line height's not going to work for this. We have to actually specifically find out the height of that property. So height, well, we can actually do that. So we're going to edit a GUI property height, give it our prop value, and this is the important thing. We must tell it to include its children. If it doesn't, we're not going to get the correct height. So we include the children, and so that looks pretty good. Now we've got a bunch of overloads for our property field. So we want to go and check it and see if it specifically has an include children, which it does, and which defaults to false. And we'll also notice that we kind of are having to make a choice with those, but we do have the get property label version where we can include children. So we don't need to make that choice, which is good. But we do here want to specifically say true. So if it's a property that's including children, so lists, arrays, anything like that, need to tell it that it's including children. Now this needs to be a little bit more clever, because it needs to not just check that it's expanded, but it needs to check the type. So this, we're retrieving the value type, we're going to have to do that as well down here. And we're going to have to do this conversion. Now we can, it's a little bit simpler in this case in that what we can just do is we can bring this into a single thing where, okay, if the value type is equal to that, so if value type is equal to eType integer list. So this is where what I would probably do is start to actually bring the height out into its own variable. So height equal to that. Just as a way of starting to remove sort of some duplication here. So height, well, we've already factored in our base height there. We know that there is going to be, at a minimum, our additional height here for, if it's expanded, we've got our ID and our type. So we can do height plus equals 2 times by our particular values here. And so that looks all right. We're retrieving that property value. And so if it's an integer list, there'll be extra things we do. Otherwise, height, we just add in another of the height spacings. And so that's good. I like to intentionally, you'll notice I'll do things here like 1 times. That's just as a visual indicator for me to make it really clear what's actually happening. So it's not an essential thing. I just find that it helps for myself for code clarity. So this case, we know we've got an integer list, so we can retrieve our property and get the height. So what we do is height plus equals, editor GUI, get property height, and we can retrieve our particular property. So for prop value, and tell it to include the height of the children in that calculation. So update the height depending on the height. And now we should see that we have this working a little bit better. So we can see that now properly expands. As we add in additional ones here, the size of this works. So this is one of the most complex use cases where we have a property drawer for something that is containing something of variable size, but that's okay, we can work with that. So key things when we're working with property drawers. Property drawers are great for that thing for where we've got a custom class that might be in a list somewhere or an array, and we want to be able to control how it is drawn. So a property drawer will allow us to do that. Property drawers, some of the stuff is a little bit more manual in terms of what we're doing, and we generally are not setting up and tracking other variables outside of our functions. A classic example being tracking for whether it's expanded. There's already values for that so that we don't need to actually set up our own additional ones. We use those existing ones. It is a bit more of a manual approach. We're having to actually draw and set positions. So that is a little bit more overhead, but it tends to be fairly similar code as we saw. So the processes, the patterns that we're following are quite similar for all of them. So with that, we can then draw particular properties. We can interrogate those properties if we need to, and only draw the things that we absolutely need. Now the catch there is we need to then also properly give it back the height. So it's our responsibility to calculate that height, which means we need to take into account if it's expanded, if it's not expanded, if it's something that that particular type has children, then we need to get the full height of that property so that everything can appear correctly. So really powerful though, because what this lets us do is we're only showing the bits of information that we absolutely need to. We're showing those key things, which lessens the potential for errors, means that we can set up some extra bits of logic here to make it a lot easier to work with, to make it quicker, and so that we're spending our time focusing on, okay, how do I make this part of the game, better? How do I improve the experience for the player? Less so than we're focusing on, okay, how do I enter the data to make this happen? We don't ever want most of our attention focused on how we enter the data. We want it focused on how do we make this good for our players? And these are tricks and tools that allow us to be able to do that. So dive in and experiment with it. See some of the cool things that you can be creating with this. Dive in and experiment with this. See with any current projects of yours if there's custom inspectors, things like that you want to set up for them to make it a little bit easier to work with. The full code for this project is available up on GitHub. I've put the link in the description below. If you've got any questions on this stuff, please do chuck in a comment. Happy to try and help out. If you found the video helpful, do chuck in a like and subscribe. Really does help out. Really appreciate it. And if you're looking for other ways to support the channel, I do have a Patreon, and the link for that is in the description below. Bye.